produce action potentials spontaneously. Am I right? Now what is the reason of this slope? From where the slope comes? Why in SN node, AV node and Purkinje cells resting membrane potential does not rest? Why in SN node, AV nodal cells and Purkinje cells resting membrane potential does not rest? It has a tendency to slip towards, yes, threshold. Let me answer this thing. Actually, in these cells, let me explain from where this slope comes or restlessness come into SN nodal cell. Let's suppose here is an SN nodal cell, right? Normally what happens in SN node, that again resting membrane potential in SN node is minus 60 millivolt and threshold in SN node is minus suppose 40 millivolt, right? And what we are talking that in the SN node, in this, what is this? In SN node, resting membrane potential gradually slip towards threshold. Now why from minus 60 goes to minus 40? Answer is that SN nodal cells have leaky sodium channels. They are having leaky sodium channels with little calcium channels. So it means when the SN nodal cells are resting, still some sodium and calcium goes in. Some sodium, we call it diastolic current, right? Some sodium goes in, some sodium is leaking in, some calcium is leaking in, right? And very little potassium is coming out. Very little potassium is coming out. So it means in SN nodal cell, when they are resting, when they are not having action potential, at that very time, cations are leaking in as sodium and calcium, and potassium is leaking out. Is that right? But leaking in, entry of sodium and calcium into cell is more than the exit of potassium. So it means cells are progressively being loaded with cations. What is happening? Cells are progressively being loaded with cations. And cells are progressively loaded with sodium and calcium, so resting membrane potential, which is minus 60 millivolt, as sodium and calcium are coming in, this minus 60 is neutralized and it becomes somewhere around minus 40 or minus 45. Is that right? And we say the resting membrane potential is moving towards threshold. As soon as it reaches to threshold, at that very potential, voltage sensitive calcium channels open. A lot of calcium comes in, and this calcium which is coming in takes the threshold potential towards the 0. Minus 40 is fully neutralized. Is that right? So much calcium comes in that threshold potential, which was minus 40, now it is completely neutralized. So what happens? The cell which was at resting time, when it was polarized its interior towards negative, due to influx of lot of calcium, now it has lost its negative polarity. So we say cell is depolarized. So it means due to leaking of sodium and calcium in, and less loss of potassium and more loss of sodium and more gain of sodium and calcium, took the resting membrane potential up to threshold, and as soon as it reached to threshold, it took off because lot of voltage sensitive calcium came in and it gets depolarized. When it gets depolarized, then voltage sensitive potassium channel open, and when voltage sensitive potassium channels open, lot of potassium goes out, and as more and more potassium is lost out after the depolarization, as voltage sensitive potassium channels open, these are different than leaky potassium channels. And voltage sensitive potassium channels are responsible for loss of massive amount of potassium, and when this potassium goes out, cell, as more and more potassium is moving out, cell is becoming again more and more electronegative because cell is losing positive potassiums, so cells start getting more and more electronegative until again it becomes minus 60 millivolt. So it means cell which has lost its negative polarity at this point due to efflux of potassium, it has regained its negative polarity. it has again become minus 60 millivolt. We say cell is repolarized. Cell is repolarized. Now, we can say that electrical potential of the membrane has come back to its resting level. But again, it cannot rest. Why it cannot rest? Because again, sodium and calcium will come in and the slope will take it towards threshold, and again, voltage sensitive depolarizing channels of calcium will open, and then voltage sensitive repolarizing channels of potassium will open. As soon as it is repolarized, again some cations will leak in and it will again take the resting to threshold, and this process will repeat every 0.8 second, and in every minute 72 depolarization will be produced, and depolarization and repolarization will be produced in acinodal cells. And because acinodal cells are connected with atrial cell, let's suppose this is an atrial cell. Now you look at this is an, okay, I'll make just under it an atrial cell. Let us suppose this is an atrial cell. Now what is happening in atrial cell? Between acinodal cell and atrial cells, there are special windows, electrical windows, which are called gap junctions. Atrial cell has a resting membrane potential of minus, suppose 90 millivolt, and atrial cell has a threshold of minus 70 millivolt. Is that right? Now you have to remember it, in the atrial cell, resting membrane potential automatically cannot move to threshold. In healthy atrial cell, resting membrane potential cannot move to threshold. Why it cannot move to threshold? Because it does not have inherent leaky cationic channels. Or to be very true, what happens that in the atrial cell,